Welcome to another presentation brought to you by Building Basics, where it's our mission statement to provide valuable education and resources to the design community. AI credits are available by watching this video and taking an optional quiz. A link will be provided at the end of the video. This program does qualify for 1/4 or 0.25 AIA Health Safety Wellness credit. Building Basics is a subsidiary of Building Multifamily, a registered provider of AIA-approved continuing education. With regard to learning objectives today, we are going to discuss key materials which make up wood frame structural components, investigate features of these different wood frame structural components, look at some of the common applications, including wood floor and roof systems, and as we go through the presentation, look at common terminology used in wood frame construction. So with regard to types of wood products, we're going to be talking about solid sawn products or lumber, veneered products such as plywood, oriented strands, OSB being the primary example there, and metal plate connected systems like trusses. Historically, lumber was rough sawn into dimensional lumber, aka 2x6. And if we go back to the late 1800s, a 2x6 was actually 2 inches by 6 inches. And then as we migrated into the 1900s, people started dressing or surfacing the lumber to make it smoother. And one of the net effects of that is that the dimensions were reduced. So in today's world, we now have a 2x6 is actually 1.5 inches by 5.5 inches, as you can see by the images below. Below is a listing of typical dressed or sawn dimensional lumber sizes. So first example, if we have a 2x4 shown right here, the actual dimensions is going to be 1.5 by 3.5. And so in this case, what would that look like? Let's say I had a 2x4. We would actually trim a little bit off of the top, a little bit off of the bottom, a little bit off of this side, a little bit off of this side, and that would leave me with this being 1.5 inches and this side being 3.5 inches. As you can see in some of the deeper depths, like a 2x14, while it's still 1.5 inches in the narrow face, the wider face, given some more irregularity with a member of that depth, would actually have 3/4 inches taken off instead of 1/2 inch. Lumber products have a few different ways to be graded. One is dimensional lumber, and that's typically in products that have a 2-inch to 4-inch thickness, and they could have different depths, 6 inches, 8 inches, etc. There's also a visual grading process for larger members. So for example, a timber is any material that's 5 inches by 5 inches and larger. And then one of the other ways that lumber products can be rated is a span rating. So one of the most common applications of this is decking. So for example, if you hear the term 5/4 board, that would be an example of a span rated board. Some of the common applications for these products, floor joists, roof rafters, studs and columns. And here's an example of a floor joist. Here's an example of a typical roof rafter, studs and columns, and metal plate trusses, floors, and roofs. OSB and plywood typically comes in lengths of 4 foot by 8 foot, with the most common thicknesses being 7/16 inch, 1/2 inch, or 15/32, shown right here. And then if you actually want to be able to see how to determine what the thickness is just by the labeling, you can actually see this example on the sheet of plywood where it says 1/2, meaning that's a 1/2 inch product. In floors, quite often those products will be 23/32 or 3/4 of an inch. And the reason for that is just to provide a thicker, more solid surface for things like tile, for walking on, etc. In addition to this, most of your OSB or plywood products will have a span rating. And so an example is 32/16, and you can see here it says 32/16. So what does that mean? That means that the maximum span that this product can have between joists or trusses or whatever it is 32 inches for a roof and 16 inches for a floor. with the mindset being that we don't need as stiff of a roof system, so we're allowed to have a little wider spacing, whereas with the floors we want it to be a little closer together. Now that being said, even though we have this piece of 1/2-inch plywood, which is code allowed to be 16 inches, have to have our joist space 16 inches on center below it. Typically those would be 23/32 or 3/4 inch. With regard to the two different products, on the left, this is OSB, and you can see the smaller flakes throughout the product. And then with plywood, it's a series of thin veneers. So one thing to keep in mind is the flakes of the wood in a typical panel. So like this piece of plywood, this is going to be 4 foot by 8 foot. So this is going to be the 8 foot direction. This will be the 4 foot. And how do I know? It's because the slope of the grain of the wood is going to go along the 8 foot direction. And with OSB, the flakes are primarily going to be oriented along that 8 foot direction. Key systems that we look at with our wood frame buildings: walls, floors, and roof systems. So let's dig into those a little bit. So first of all, with our wood frame wall components, we have the double top plate, whereas we take two pieces. Quite often, if it's either 2x4 or 2x6, depending on the thickness of the wall, we'll have two of these products on top of each other. And there's a number of things that does for us in our building system. One, it provides this continuous strip along the top of the wall. It also provides a stiffer ledge, if you will, for our floor joist to sit on top of that. If we only had one top plate, then we would probably need to make sure that the floor joists or the roof joists are lining up with the studs. Otherwise, we could get too much deflection in a typical single family construction, if you will. Then we have our headers, which go over windows, and then the sill plate or bottom plate, which goes at the bottom of the wall. Other key components in our system are the wood studs, which are typically spaced 16 to 24 inches on center. We have jack studs. So the jack stud is going to be a stud which supports a header. So you can see in this example that there's a header directly over the top of it. And then we have king studs, which are just to the outside of the header. And so one of the key functions of that is it provides stability for the windows or doors, for example. Now let's take a look at the columns, which are going to be a key component in our wall systems. So first of all, we have solid columns, and so you can see there's two different ways that these can be put together. So in the first example here, we have a solid column where it actually goes through the double top plate and the bottom plate. So why would we do that? Well, when we actually take it through the top plate, we're going to increase the capacity of the column. Why? Because the perpendicular to grain strength of wood, or the pressure on the side of those top plates, does not have the same strength as if we're pressing on the parallel grain on the top and bottom of the column. We also have the second case where maybe we don't need all that column capacity, and it's easier where we'll just have the column butt up to the underside of the top plate or to the bottom plate. And then we also have built-up columns, which are shown here, where we'll take multiple 2x materials and bring them together to form a stud. One of the nice things about doing this type of construction is that if you're already ordering material for your studs and plates, you can use that same material to create columns. And there are some minimum staggered nailing requirements when you connect those studs together. Now let's take a look at some of the sheathing components that can occur on a typical wood frame wall. The first piece would be the gypsum, which is typically on the interior of the wall. That would often be a paper-faced gypsum, so that can take a coat of paint. And then on the exterior of the wall, when we're looking at wood frame construction, some of the more common materials would either be an oriented strand board or a plywood going on the exterior. In wood frame construction, roofs are quite often sloped, and those pitches could be 412, 612, even as much as 1012 in a lot of cases. And with rafters or trusses supporting that roof system, often spaced at 24 inches on center. So as an example, this would be a solid sawn rafter. And then often these are going to be sheathed with OSB or plywood. So there's an example, the OSB between the trusses. You can also see over here in between the rafters, the OSB also. Well, the most common application for trusses is in the roof. Trusses may also occur in floor systems. So this gives you an example. This would be a plated floor truss in a floor system. You can see it's supported by a steel beam. These do have metal plate connections. There's a good example right there of a metal plate connection. And one of the other products that's also available that's quite often used in floor systems would be an I-joist, and that's shown in this photo right here. And these products have a flange, which is either going to be made out of sawn lumber, or it could be made out of a laminated veneer lumber or an OSB, and then an OSB web material. And these are really meant to replicate a steel beam, if you will, more efficient use of our materials. Some of the benefits to a plated floor truss is you do have this openness in there to allow mechanicals to run through. Now, if you are doing an I-joist floor system, there are opportunities to cut holes in the material. You've got to be a little bit careful about where you put those holes. But as you can see over here, you are allowed to run pipes through that also. So in both cases, you can get that openness needed to properly plumb, wire, etc. at your home. And one of the key components whenever we are working on a project is building this openness, whether that's for windows or just open spaces, which have become a lot more popular. And so that's where beams and headers are going to come in. And so this is an example where we have a header going over a window. Right now, since it's under construction, the header is or the opening is covered up with a sheet of OSB, but eventually there'll be a window that goes in right there. As far as beams, they could be flush or they could be dropped. And so to give you a little bit of understanding on that is a flush beam, which means it's in the same depth as the floor system. You could alternatively, if you don't mind having that beam visible or dropping down, you could actually drop it down and have the I-joist run over the top of that if you wanted to. Some of the common materials that are used in beams and headers would be sawn lumber, which is shown right here, or we could have a glulam or a laminated veneer lumber, and this is an example of a laminated veneer lumber. One thing to keep in mind with all these materials is they are bonded with thermoset adhesives. So if you are wondering what's going to happen if there was a fire or if they get wet, there should not be a concern with the resins debonding these materials which have been glued together. So to recap, we discussed some of the key materials which make up wood frame structural components. We investigated some of the features of these different wood frame structural components, where they're commonly used in wood, floor, and roof systems. And we also just went through some of the common terminology used in wood frame construction, things like headers, beams, flush beams, etc. So to wrap things up, if you would like to earn AIA credits for watching this video, go to buildingbasics.org/CEU and you'll find a quiz that you can take. And once you complete that, you'll get an email back from admin at Building Basics saying that you've completed it, and a certificate will be emailed to you along with AIA credits getting reported to AIA. Hope you have a great day. Thank you so much.